Hey everybody, hey YouTube, how's everybody doing? Welcome to problem 2 of our Power 25 series. If you guys haven't seen problem 1, I made a kind of video about explaining what the Power 25 series is and more on that problem. So just a quick overview, these are the 25 most essential kind of foundational questions when you're doing LeetCode to even start off that are just key and kind of prime for all of these software engineering interviews. So definitely use this as a great basis to kind of go about difficult and different problems. So this should be a good foundation to kind of approach other problems. So let's get started. So today we're doing maximum subarray. So it's a very good like ratio. Given an integer array nums, find the contiguous subarray. So that's containing at least one number, which has the largest sum, and return its sum. And the follow-up, if you have figured out the ON solution, try coding another solution using the divide and conquer approach, which is more subtle. So more on that. Kind of that's the solution that we're going to be doing today. And example 1, so example 1, our nums is equal to -2, 1, -3, 4, -1, all of these numbers, and it's 6. So why is it 6? The reason it's 6 is because out of this entire array, there exists a contiguous subarray. So what does contiguous mean? Contiguous means that a subarray of this array just has to all be adjacent to each other, right? So -2 and then this 4, -1 here, that's not contiguous, right? But this it's like a block. So this 4, -1, 2, and 1, that's a contiguous subarray. And the maximum contiguous subarray out of all of these is the sequence 4, -1, 2, and 1, which yields a 6. Hence, we would return our sum, which is 6 here, right? And these are other just examples, kind of if there's one array element. So yeah, how are we going to sort of solve this question, this divide and conquer one pass question? So what I like to think of when I do divide and conquer and stuff like that is, let's just think of it as the most fragmented kind of piece by piece. What's the smallest piece we can chunk off with this array? Well, this is a huge array, right? There's a lot of numbers. So let's break it down. What's the maximum subarray if this array was just -2? The maximum is very trivial. It would just be -2, right? So yeah, you're saying, okay, that's fine. So now, what's the maximum subarray? Let's kind of slide our pointer. We're kind of including these two index. So what I'm saying is, what's the maximum subarray at index 0? It's just -2, right? What's the maximum subarray of all the elements at index 1 up to index 1? Right? So this is a very key kind of algorithm that we're using. We're using a thing called Kadane's algorithm. I know it sounds scary, but it's very simple. So notice how in this example, we're going to make 3 comparisons. So the maximum subarray of sort of this example of -2 and 1 is basically just going to be the max of sort of our current max that we're our running current max. So if we kind of start off here at the 0th index, so we know we can establish the current max and the global max at -2, and we move on, right? So if we go here, our max is going to be kind of what the current max is, and so it would be the current max. So I would say current max plus adding the number and the number itself. So what do I mean by that? So notice how this array has negative integers. In positive array, integers would be very trivial, right? It would just be the entire array. But we need to account for these negative numbers. So what I'm saying is -2, right? So current max is -2, right? And our 1. So -2 plus 1 is going to yield -1. So that's great, right? So it's basically saying that's a possible subarray, right? If we include this -2, 1, that would be a subarray. Another subarray would just be the number 1 itself, right? And why would we include -2 plus 1 when we have this 1 itself? So this 1 itself is by definition a greater subarray because it's just the sole element. So we make this max comparison of, should we add this particular number to our current max, or should we just start out at the exact number that we're on itself? It could actually be higher than our current max. So we observe this and we say, okay, well, our current max is actually going to be 1. And then the global max is basically just keeping a global counter of all the current maxes. So it will be the max between the current max and your global max. So then both of these will be initiated at 1. And then we proceed on with the iteration. So let's go to the next thing. So we can see here that -2, 1, -3, right? So now what is our current max? Our current max is 1 because this is saying, hey, let's start at this 1. So our current max is 1, and 1 plus -3, right? Should we add this -3? Well, that would be a bit costly, right? So our current max is going to be 1 plus -3, which is going to equal -2. Or should we just start at the 3 itself? Well, it's the max between -2 and -3. So what are we saying here? We're saying, should we be including 1, -3, or -3? Well, we should be including 1 and -3 because, right, the 1 plus -3 is -2, and we should keep that as our current max. So now you're saying, so now our current max actually becomes a -2, right? Because these are contiguous elements. This is our iteration right now, 1 and -3, but our global max is the max between sort of 1 and -2. So it's the max between our previous global max and -2. And we're saying, okay, we considered all of the elements up to here, right? So if you look to the left of this box, -2, 1, and -3, the best possible case that we can do is this one. It's just this one. That's the max subarray of this index. And we just slide our index and we apply the exact same logic. We're dividing and conquering. That's all there is to it. So now we have our current max is -2, so that's saying 1, -3, and then we have a 4. So the current max is -2 plus 4, right? Or should we just start at 4 itself? Well, -2 plus 4 is 2, and we should, start at the 4 itself, right? And then it will be the max between sort of this 4 and this 1 and this 4, right? So we see here that our current max will actually start at 4. Our global max will overwrite because 4 is greater than 1. And we just keep doing this. We move on to sort of the next sort of iteration. And the max subarray at all the elements up to that 4 is 4. It's just that element here, and now we keep going. So we'll go a little bit faster now. So the current max is the max between 4 plus -1, and should we start at -1? No, because 4 plus -1 is 3, so we shouldn't start at -1. So our current max is going to become a 3, right? And our global max is not going to overwrite, right? Because if we kind of slide our array and we do all the elements all the way up to -1, we're still going to choose the 4, right? Because -1 will just decrease its value. So we're going to go a little bit faster now. So basically now we are doing all the numbers up to this 2. So our current max is 3 at the moment. So our current max is going to be the max between 3 plus 2. So should we add 4, -1, and 2 as our max subarray? Or should we just start at the 2 itself? Well, 3 plus 2 is 5, and that's greater than 2. So our current max is going to be 5, and our sort of global max is going to overwrite, right? 5 is going to overwrite 4. And now we're doing the exact same thing with the 1. You can see how 1 will just overwrite our current max to 6, right? And then our global max will overwrite that. And this 5 is it's gonna take a hit, right? Because should we do 6 plus -5 or start at -5? So we shouldn't start at -5, but we're gonna take 6 plus -5, which is gonna be a 6 plus -5 is just gonna be a 1. So this whole array here currently is going to yield us 1. But the global max is not gonna update. We don't want to update that. And lastly, we're going to go to this 4, right? We're going to increase this. So should we do 1 plus 4 or stay at the 4? We should do 1 plus 4. So our current max is going to be 5. So this whole thing is going to yield us 5, right? This whole subarray here. But that's not going to trump our global max, which is this array here. And we can see that we're making kind of a sum counter at the entire time. Hence, we would return the 6, which is our maximum subarray of this given array. And I hope that makes sense. This operates in O of n time and actually O of 1 space. And if you're not familiar with that, like I said, I'm going to do another video kind of discussing time complexity. But without further ado, let's go ahead and get started into the coding. So first off, we need to do our kind of fragment, our kind of base case. So basically for this, our sort of current max, right? It's just going to be nums of 0. It's going to be the first index. And our global max is also going to be the number 0. So we're initiating the -2 here, right? At the very beginning, we're saying, okay, well, the maximum of the indexes up to 0 is just -2. And we're just going to say for num in nums of 1. So this is just notation to say, oh, we're going to start at the first one, right? We don't want to start at the 0 with 1 because we already initiated it. We're going to say, okay, well, our current max is just going to equal the max of our current max plus the number, right? If we want to add that to the iteration, or just the number itself. Do we just want to start on the new pivot, on the new number, right? And our global max is going to say, oh, look at all of our current max iterations. This is going to be kind of the ultimate global max of all our current maxes. And at the very end, we have our global max, right? Even though that this whole thing yielded 5, our global max was 6, right? Because we wanted, this is even better, this kind of subarray, right? And at the very end of the day, we're just going to return our global max and see what happens. And this actually runs very well. This is the divide and conquer approach, 98%. And that's it, guys. Thank you so much for watching. Hopefully you guys, thanks for making the time, and I'll see you guys in the next video.